I will talk about AI, some basic concepts for the first part of this talk, and then my colleague, Dr. Raza, will take over for the second part. So for my part, I will try to answer some basic questions about AI, such as what is AI? Is AI possible? How is AI possible? What can AI do if AI is possible? And I will cover very briefly because this, with limited time, I try to answer these questions, very basic question to AI. So firstly, definition of AI. So artificial intelligence has some history. As a terminology, it was coined first time in 1956 by Professor John McCarthy for publicized conference. However, by now, there is still no consensus on the definition of AI. So I try to give you two popular definitions. The first one is basically by Turing. By the way, Alan Turing and John McCarthy are two big figures in the history of AI. They made huge contribution to AI. So the first definition I would like to give is based on the Turing's definition. So AI is building machines that can think, can learn, can act, and feel like humans. So in original Turing's definition, AI is about machines that can think. Now extend to machines that can think, can learn, can act, and feel like humans. Okay, that's the first definition. The second definition, there are many different definitions. There's no consensus, as I said. The second definition, AI is the science and engineering of making intelligent machines. This can be very easy to be accepted because this is just intelligent machine, but there's no specific definition about intelligent machines. If you think intelligent machines are those that can think, learn, act like human beings, then we combine these two definitions. So basically, remember this, AI is about machines that can think, can learn, can act, and feel like humans. Okay, that's the simple definition. I think it's very easy for you to remember. And then although there are many news about AI, the breakthroughs of AI, and most of applications, lots of mobile apps about AI, but it's still controversial about this question, whether AI is possible. Is it really possible? Maybe it's quite depending on the definition, right? So actually, over 100 years, people have been arguing about whether AI is possible, from Aristotle in the ancient Greek until now. We're still not consensus on this, whether AI is really possible. If we define AI as a machine that can think, can learn, can act, can feel like human beings, we still don't know actually whether it's possible. So just tell you a little bit of history. So there are lots of people in the history argue that AI is not possible. The famous one is the Lady Lovelace objection. She is the, maybe you already know, Lady Lovelace was the first program in the world when we have the Babbage and Lattice aging, and Lady Lovelace developed first program for computer. And her objections like that, computers can not really think because they can only do what their programs tell them to do. That's about 200 years ago. And there are other objections to say that AI is not possible in the history. And until 1950s, Alan Turing rebuffed this objection and other objections. And his argument that machine can think because one, machines could be programmed to learn. And secondly, the results of programming often surprise us. It could be unpredictable. So in that way, machine is possible. Machine can think like human beings. And he also proposed a test, now we call it the Turing test. When a program passes the Turing test, then we can say the program or the computer running the program can think like humans. And there are some news to say that there is a program that has passed Turing test, but that's not have been widely accepted. Even for me, in my opinion, there's no program at the moment that has really passed Turing test yet. I will talk a little bit more about Turing test later. So, where's my mouse? Oh, sorry. So, it's possible. I think if we define AI generously, just like in generative machine, then we can say AI is possible. And how is AI possible? There are three fundamental approaches. The first one is state space search for problem solving. So we have smart search strategies, search algorithms, and evaluation functions. For example, we can develop AI for game playing, like the game of Go. That's the first fundamental approach to AI. The second fundamental approach to AI is knowledge representation and expert systems. For example, medical diagnosis expert systems. So this is focused on the knowledge representation and the use of knowledge to solve problems. That's the second approach. The third fundamental approach is machine learning, especially deep learning. This is the main approach now for AI. There are various machine learning models, algorithms, for example, for understanding environment, for making decisions, and as example, self-driving cars. That's through deep learning we can understand the environment, then make decision in driving. So this is three fundamental approaches that make AI possible. And here I just show you example of machine learning for emotion recognition. So how is it possible? Machine learning is one of the three fundamental approaches. Machine learning can be used for pattern recognition, for automatic control, and many other applications. Here I just show you an example of machine learning with neural networks or deep neural networks. And the neural network can be represented graphically in this way, or can be represented by equations. Here we have a model which just shows the input-output relationship of the neural network. For example, input of image with a happy face. If the neural network have been learned properly, then the output should be happy. So we have a neuron responsible for happiness. If the image is happy face, then the output neuron would be activated. Otherwise, if a sad face, then this happy neuron, the neuron of happiness will not be activated. And the machine learning is about how to change the neural network so that the neural network will have this function for emotion recognition. Start from random connections, random structure, the neural network will behave randomly. It's a happy face, the output could be happy, could be sad, could be neutral. And if it's not right, then there would be error. And the learning algorithm is very smart. Based on the error, the learning algorithm will be able to change the weight so that the neural network will perform better and better after this weight updating according to the learning algorithm. So this is like human learning from examples. Happy face, output should be happy. If it's not happy, there would be error. Based on the error, we change the connection weights so that the network next time will recognize a happy face. If it's a sad face, then there is a neuron for sad face that should be activated. If it's not, then there would be error. And by using this error, the learning algorithm will change the weight, like increase or decrease weight value so that the network can perform the recognition correctly. And so that's the way. What is AI? How is AI possible? So if AI is possible, where we can find the applications of AI, I think this is my last slide. It's very easy to show you. AI can be applied to many areas, like a human being. What human can do, AI normally or almost can do what human can do. So can perceive the environment through speech recognition, image recognition, face recognition, and so on, or from natural language understanding, can understand the human beings, can understand the environment. Also, through machine learning, the AI can make decision and can take action and can respond to the environment, including humans. So there could be interaction of humans. So that's it. For my part, maybe a little bit over time. So I pass it to my colleague, Dr. Raza, to continue to talk about teaching and teaching and research in AI at Essex University. So,
and what we do at Essex in artificial intelligence, we have a massive group of artificial intelligence as Essex. We do both research and teaching. So I will introduce means first with the teaching. So in teaching, we have a program which is module name is C231 Artificial Intelligence, and it's a second year module in undergraduate. And I believe Professor Gan takes that module. Yep, so he led that module, and there is another module in graduate studies, that is MSc in Artificial Intelligence, which is a full degree course designed around various themes of artificial intelligence. And we have provided you a link over here if you want to go and find about a detail of this course. You can just click on this links, guys, after this means webinar, and you can have a detailed look at what are the subjects we have in the module, what topics we teach. But I would like to cover what we have, what we do in research at Essex is we have a hundred means we have tens of academics, and many PhD students are conducting research on fundamentals of AI and machine learning. Within the Essex, we have a School of Computer Science where we belongs to, and I especially work in the Institute of Analytics and Data Science because there means I belongs to this research group. And in the group, if you say, we have various themes in AI. So as Professor Gan shown that AI can be applied in various fields. So we have various groups within the Essex. The first group is AI for decision making. So we use AI for make intelligent decisions, or you can say informed decisions. So based on the data which we have, we do machine learning, we do other type of AI to make a better decision. We have another group which is called brain computer interfacing. I'll go through each of the group in the couple of slides. Other group we have robotics and mechatronics, and another research group is natural language processing and information processing. And another research group we have intelligent embedded systems environment. And all these research groups use AI to complete their research, to implement their research work, right? So now AI for decision making, what I would say that AI for decision making is you can see that what we do in this group, we have a couple of faculties, we have researchers, PhD students. So we use data and we use the prior information, or we can say what we have in the data. We learn some type of models. What Professor John has shown you, that we learn some kind of mathematical models using the equations. We learn from the data, and using that we do reasoning. We have some constraint to learn the model. We do causal modeling. We plan the route. So for example, if you say that somebody is diagnosed with a cancer, right? And we can plan his pathway, or you can say his treatment, his or her treatment, that this is his past history, that this guy has this history, and he or she has been diagnosed with the cancer at this stage. So what is an optimal path for his treatment so he can get better? So using this all data, we can find a better path to treat someone, so we can save the life. So within this group, what we do, we build good artificial intelligence based decision making softwares, which can be used for finance industry, which can be used for businesses, which can be used for healthcare, for crime preventions. And this is one of the group we have. Other group we have is brain computer interfacing. I'm also a part of this group. I'm also a part of AI in decision making group, because I did my PhD in this brain computer interfacing, which involved a lot of artificial intelligence. So what we have a very well equipped laboratory within the Essex, which is, I believe, one of the best laboratory within the Europe. I would say that we have a lot of equipments to record the data. So we invite patients, we invite healthy participants to take their brain signals, and we build computational models. We do research on neuroscience, that we can detect human intentions, you can say, or their attempt to control computers. And using those computers, we can control some kind of devices, such as you can play games, you can You can hand means somebody can have a artificial hand. They can do exoskeleton based means handling. They can write on the screen. They can use their eye to write on the screen. So this is all research we do in brain computer interfacing, which involve again building of models, learning from the data, intelligent way of cleaning the data. So this group basically focused on this. Another group we have is called Robotics and Mechatronics. This is also a very specialized group within the Essex, and we have a very large setup, a very huge setup of both robotics and mechatronics lab. And the type of research we do in this lab, the PhD students, the staff, the professors, they are working on building a smart 3D printers. Couple of students and researchers doing autonomous driving, working on domestic assistance, creating healthcare devices, smart devices means which can work on very less calibration time. We do industrial manufacturing in this group. We search and we build system for search and rescue operations, and many more. We have another group, as I told you, that is natural language processing group. This group is also a very interesting group because, as you know, that the amount of data on the web is growing day by day, and majority of the data is coming in the form of text, right? So if you want to make intelligent decisions, so for example, if in some country there is election is going to happen, right? If you want to know what is the people trend, to whom they are going to vote, who's going to win, or for example, if some football match is going on, like you can analyze the sentiment of the people, that who's going to win, what people are supporting them. So, like these type of text information is available online in the real time. So what we do research in mining, in extracting the information from the text. So we do machine translation, we do information retrieval, we do sentiment analysis, we do information extraction, we develop intelligent chatbots, or you can say bots, which can question answer to the queries on some websites you see, or maybe in an airline or somewhere we use intelligent chatbots. So this all involve natural language processing. So we do that as well. We have intelligent embedded systems. So we do cyber crime, cyber physical systems also. We do Internet of Things, network and distributed systems, or sensor nodes, you can say, a real-time critical system, and we build smart infrastructure. So in this lab, we have a laboratory, which is called iSpace, which is a very high equipped living house kind of thing, where we have IoT sensors, cameras, and nodes, and means a lot of smart system is there. So we build and develop smart homes, or you can say smart infrastructures, or you say future cities. We do research on that as well. And that also involve a lot of AI, because we need to build algorithms, and in building an intelligent algorithms, we need artificial intelligence. And so this is all what we do, means this is just a part what we do, because in the very limited time, I cannot cover so much of things. So what I would like to conclude with this point, that whatever the AI is there in the academic and in industry, we have means the theme of AI is we aim to build machine which can think like human, or we want to build a machine which can act like human, machines that think rationally and that act rationally. So rationally means like which make optimal decision, like means exact correct decisions. So so these are the four themes around all which AI involves. So if you say AI machine that think like human, we are trying to build a system with things, right? Acting human, like building robotics, brain computer interfacing, thinks rationally, like, so all the themes which I have covered within my slides, within my presentation, which revolves around this. And I think I would end my presentation at this point.